Hey guys, and welcome to my channel. This is my first video about Blender and geometry nodes, and today we are going to learn how to create a Dex card maker procedural method in Blender. Let's get started. I'm working on Blender version 3.2.1. We have a general and empty project. We have to add a new card. I press Shift A, Mesh, add plane. I'm copying the size. For I will solidify. I will use a modifier named solidify. Okay, my thickness is this. Apply. I will bevel. Will bevel some segments, some edges of my geometry. To do this, you have to press Tab to enter in edit mode of your geometry. Select the edges with the 2 on the key 2 to enter in the edge selection, or in the top left. I select with the Shift all my segments. I set to them a value of 1 in this edge data min lever weight that let us to bevel only these edges and not all the edges of our geometry. So we have to go here in the bevel modify limit method, weight, and voila. But there is a problem. We have to specify the amount of our bevel to 5 millimeters, and this is a bad result. Why? Because we have a wrong scale in this geometry. So to make it better, I press Ctrl A, apply scale, and voila. I could smooth this geometry a little better with right button, shade smooth, but this is a bad result. We can have a better result going to this object data properties, and on normals section check auto smooth. Okay, and this is the result. Okay, a fake smooth of our geometry that has low poly, low number of vertices and faces. This is the card. We name it card, save our project. Now we go on geometry nodes. You can choose some way to go inside the geometry nodes, but one of these methods is this button plus general and geometry nodes. These layouts changes. You have to image that would have some Dex cards on any kind of surface. Okay, a sphere, a plane, a mountain, a river. I will add a plane, our table. I add geometry nodes. Keep in mind that we have to add some decks. Each deck will contain some cards. Okay, so we can distribute points on faces. Okay, this is the positions of our decks. I choose Poisson disk to have a distance, a minimum distance from each dex to avoid overlapping. Okay, a plane is too big, 1 meter per 1 meter. Okay, you can imagine a curve that blend, okay, following a function that help us to be more clear in the smoothness of these curves. We can use a sine mathematical function. Okay, so I add a simple curve line with Shift Alt and click. You can isolate the selection to what you selected. I have to adjust the end point. We have 1 meter, 0 and 0. Okay, this is the curve that contains points where there will be our cards. We have to resample the curve with F3 resample curve. So before my English, it's not absolutely perfect. This is the cards each deck. To see them, we have to set position of the points on our curve. We have to slide the points on this curve with the sine mathematical function. We have a spline parameter that has this vector. It's an attribute that let us value from 0 to 1. Okay, 0 in the start of the curve and 1 to the end of the curve. We can apply some mathematical function, math. We have to apply the sine, but we have a problem. We have to map a range of this value, not from 0 to 1, but from 0 to pi. Because if you remember the shape of the sine, we want only the positive part of the shape, and so we have to map range where we have a factor mapped from 0 to 1 to 0 and pi. We have to calculate the sine, and we have to combine the result in a vector, because the set position needs a vector for the offset of the position, for the position of each point on the curve. So we have to move bend the curve on the y-axis, and voila, we have the curve bended. If you change the count, the number of points changes. We have to slide the entire number of points of the distance from the end point and the start point, divide by 2, because after, when we will rotate the entire deck, okay, we want to rotate from the pivot point, from the center of the curve, and not the start point. Okay, the result is not this, but this. Okay, to have this, we have to set a value, the end point, so we have to combine xyz value on the x-axis, vector in the end. The result is the same. We have to get this value, divide by 2, and we'll use this for the x-axis, not 2 but -2. Okay, each card of each deck is not perfectly aligned in the z-axis because they would overlap each other. Okay, we have to shift each card of each deck a little bit. Of what? Of the height of the single card. We have a value named thickness card. This is the thickness of the card, and we have to multiply this card for each index of our point on the curves, okay, and we'll use these with a Z part. And if I, yeah, okay, this is the result. More count, more cards, more shifting of each point on this curve by the thickness of the single card. We can save this value out of the box, out of the geometry nodes system, to manipulate better the parameters in this zone, in this section of the modifier. So we can have a density mean, seed. You can drag and drop the attribute you want to save. Oh yeah, this is this. Okay, we can kill this attribute, this value. Name density, okay, density, okay. X length deck, okay. We have a number, cards per deck, okay. Min, max, okay. Length from 0 to 2 meters. Save the project, and we have this, okay. Now we have the curve. You can shift, alt and click to see yes, density and length. So this is the length. Perfect. We need a value to multiply this bending, so we have to have a value, okay, to not here, sorry, in the sine value, okay, double, okay. So we can adjust the bending of the curve, okay. I can use this like an input named curvature, okay, and voila. So I have to instance now this curve on my mesh. Shift alt click, and this is the point of the decks. I can instance on points what, this curve. Ta-da! We have some decks on our table. We have to rotate in a random. I can add a random value. I need a vector value because the rotation is a vector. Perfect. But this is a bad result because I have to rotate only for the z-axis and not the other axis. We can use a map range to choose a value from 0 to 1 to 0 to 2, multiply pi, so 360 degrees, but in radians 2 pi. We have a vector here and a value here, so I have to combine x, y, z. I use the result only for the z-axis, the vector into max random value. I can duplicate the group input where I want and add my value to the group input named rotation decks. I can randomly rotate the decks on our table. So now we have to position our cards, and the most important part is the rotation of each card on the normal of the point on each curve. So we can drag the card directly into the geometry nodes, and we have two instance on points. So I drag the card and voila, we have cards. And look, the height of each card, okay, this is, they are shifted by the height of the card. We have to rotate each card by the value of the normal, you would think, but I prefer use the tangent value. So we have to use a line Euler to vector. Okay, use this from the rotation, and this is the results, but there is a problem because we have to use only the z value of this vector. So we can combine this value here and use this with the rotation, and voila, we have a perfect alignment. So if I increase the curvature of my curve, I have the result correctly. Save the project. We can rotate the each card independently with a random value. Here I can add a vector math to add this with a random value. Again, I can copy and paste this map range and these three nodes. Voila, this doesn't work. Okay, I can link this and use with a value that I can export in the group input and rename in rotation cards from 0 to 1. Rotation decks the same, from 0 to 1. 1 is 360 range degrees, and then the range of a random value from 0 to 360, and this is the random value. But you can see there is a bad result because I increase a little bit the minimum distance. Okay, you can see that each cards on each deck rotates in the same way. To avoid this is because the tangent value is cached for the same original curve that we created. So to avoid this, we have to realize instance of our curve. I explain. If we press Shift Control click, we have in the spreadsheet in the top left part of the screen 5 instances that contains information of a tangent of the same points on each curve. So an example, if we use random value, it will use 5 to 8, 5 to 8, 5 to 8, 5 to 8, etc. So if we have this, Shift Control click to view a preview in the spreadsheet, we have 50 control points. So we have all the control points independent from themselves. Okay, we can use the rotation of the cards independently. Okay, but there is a problem now. If I use the rotation deck, I have this weird behavior. So to avoid this behavior, I have to fix this problem. I need to separate XYZ and use only the Z value, okay, of my tangent aligned vector. So in this case, I can randomly rotate the decks and also randomly rotation of cards. Okay, I can adjust the length and whatever you want. So make this in a form readable. And voila, this is the flow. We have the group input, we have the creation of the curve, okay, we have the end point of the curve, we resample the curve with a number of cards of each curve, we set the position XYZ of the points of the curve, shifted by the endpoint divided by 2 on x-axis, the sine mathematical function applied to the factor of our spline, our curve, and range with a range from 0 to pi, and shifting in the height by the thickness of our card multiplied by the index of each card. After this, we have to instance what? This curve on the points that we created on our table. Okay, and we have a rotation, a random rotation of the deck. Okay, we have this rotation deck random, so we can increase the density of our decks, decrease this minimum distance, and we have lots of decks. And then we have to realize instances to have a different value for each point where the card would be placed. So we have to instance what? The card, and let them to rotate randomly with this schema. After that, we have to apply a material. So I can set material with each instance. Look at this. We have not one geometry, but we have lots of geometry, lots of objects. Okay, so we have to assign a material card. I choose card, so we have to go to the shading section. This is my shading. So because we have lots of object, we have to get the random value from each object, not a random per island, okay, of my geometry, because I have not one geometry, I have lots of geometry. Okay, so shift control click, click, voila, I have a random value from 0 to 1 that I will use to do some tricks. I saw on internet an image that I drag in this environment. The image is this, so you can see all the cards of one deck. Okay, 54 cards. We have to do in UV editing. We have the single card hide. We use only the card, assign the same, okay, the same material is no, so I have to select the card, select card material, okay, go up, right click on the viewport shading or Z key and material preview. It's the same way. In the shading I link the card color to the base color of my principal shade. Okay, and you see the entire image on the single card. I don't want that. I want to scale the UV map of the top face of the card, the single card, to have the size of a single card in the image reference. To do this, we have to manipulate the UV tab to edit mode, 3 to select face selection, select the top face of our geometry, and right the mouse button, and UV unwrap faces unwrap. Okay, we have the in the UV editing we have the face. I will scale this, but there is a problem. I want to fit this size to the entire image reference, so then I will scale it again. So I enable this magical value constraint to image bounds, so we can go to the vertex selection with key 1, select the vertices, G to move X axis of the image. So now I go to key 3 to face selection, select the faces, and we have from 0 to 1 we have 13 cards. Okay, so I have to divide 13. 1 divided by 13, this is magical number, scale X to 0.0769230769 blah blah blah. The same in the Y axis, so we have 5 cards, so I can scale it in the Y axis and input 0.2, D to move, and I have the correct mapping? Not yet. The rotation is wrong, so I will do again. G. Rotate 90 degrees. So scale, vertex, selection, vertex G, X in the same, selection, vertices G, Y axis at the end to size all. Now it's good, this representation, okay. The view, face selection, scale, X axis to 0.076923076923 blah blah blah, and scale in the y-axis 0.12. G to move in the top left corner. Exit from the edit mode, go to shading, and now we have what? We have to offset the position of each card thanks to the random value with a step. Okay, we have to snap the shifting by the distance between card on the image reference. Okay, so 1 divided by 13. And math, so we have to another group of math, one for the x-axis and other one for the y-axis. We have to click Ctrl T to have texture coordinates UV map on this card. This is the selection of the UV. It's correct because we have to follow the UV map and on the other automatic generation of the map. We have to use this vector location, the location vector, and these three axes, two axes, to offset each card randomly from 1 to 13 and from 1 to 4. Okay, in the y-axis. So we have to offset this, we have to snap the rotation. And to do this I have to snap the random value with 1 divided by 13. Okay, or you can use math node and use this technique, 1 divided by 13, and use this value output to the snap input. Okay, the same 1 5 snap. Okay, so we can use the random value to snap it and use with a combine XYZ node to have a vector of the output, because we need a vector. Value of x is okay, value y, value of y is okay, and you can see the perfect offsetting. But there is a problem. I can show you in this way. We can turn off the car, turn on the plane. This is the first weird effect. So if we offset the location of the mapping of our card, I cut this for a moment. If I offset with a positive number, you can see, okay, we go up and not down, because the point of origin of our image reference is in the bottom left part of our image reference and not the top. Okay, in the bottom left, the x-axis goes to the right and the y-axis go to up. Okay, so we have to invert this number to with minus value, so I can multiply this snapping with -1. No, because there is another part. We have to offset not only only for these 4 rows and not all 5 rows. So we have to map range this value of random from 0 to 1 to what? To 0 to min 0 and max what? 1 1 subtract what? A single card. Okay, I want to offset the card only for one row, the second, the third and the fourth. Okay, not the fifth. So it doesn't work. Why? Oh yeah, I forgot. I forgot to use this map range value to my new node. Okay, cut this node and voila, we have the offset. But there is another effect that we can see if I choose different values of group output. Rotation cards no, leader curvature, length deck. Okay, so you can see that the cards used by the system seems to be similar. You can see that only a portion of this image reference is used in the system. So in detail, this portion, okay, of cards. Why this? Because the same random values used for the snapping of x-axis is used also for the y-axis. So if we have a number of 0.1, okay, from 0 to 1, 0.1, we have a little shifting in the x and y, okay, in the same way. If we have 0.9 value, we have a big offset in the x axis and a big offset in the y-axis. So these cards are the only used, and this portion you will never see in this configuration. Okay, 5, 8, 10. Okay, so we can fix this problem in one way. We can use a noise texture, okay, with a one dimension. So we can input a random value to have a second random value calculated on this noise texture. So we can use this factor as a new random value. The factor is from 0 to 1, and voila, we have all the cards from the image reference used inside the project. So we can see okay, sorry, I added a noise, but we have to white noise. Okay, one dimension, one value, one value, one value. Okay, this is correct. Okay, perfect. This is the tutorial. You can create some configuration like these, the length and the curvature, or yes, some little rotation, a complete rotation of decks, density increase, and lots of decks, and you can manipulate the seed of the entire distribution. So you can card length, we can have a minimum density, okay, and distribute, not rotation, no cards, rotation, okay, top view, and voila, we have the length, the number of cards we can increase, and you can do a lots of stuff. So thank you guys for watching this tutorial. I hope you enjoyed it, and if you want some information or other tutorial about geometry nodes, you can simply leave a comment and subscribe on my channel if you want to follow my other tutorial about it, about Blender and about geometry nodes. So see you